Hello, everybody. In this lecture, we will talk about concept selection as our next step in the engineering design process. Assuming that we recognize there is a need, there is a market for a product, we define our problem, we generate some concepts. In this lecture, we're going to learn how we can choose the best concept or how to rank our concepts. To do so, obviously, we need a set of alternatives or concepts that we have already generated. We need a set of design criteria so we can compare and rank our concepts. And of course, we need a mean or a method to evaluate and compare this design. Keep in mind, our goal here is to select the best concept. Well, there are two ways that we can do it. One is an absolute comparison, meaning that we just compare a concept with a set of criteria. We'll look at feasibility, our intuition, experience, based on modeling, decision based on modeling or analysis. Or we'll look at the available technology or technology readiness, maybe customer requirements, maybe they don't like a concept. And relative comparison, or which is also known as decision matrix method, which we compare concept with each other. Well, as a result of each method, the first one is going to lead to a go, no, or go or no go, or yes or no for a concept. And the second one is going to be the ranking. What is our best or first rank concept? What is the second? And so on. Keep in mind, sometimes maybe our idea or a concept is the best, but the technology is not available. Maybe we cannot manufacture it. Look at the examples in history. It takes a while for a technology to be really mature and ready. For example, it took almost 4 centuries until human flight became mature and available. Or the example of radar, it took 15 years until it became available to be used in practice. In modern day life, the AI and machine learning, which is available now, initiated before 1990, and it took 2 decades until we have available powerful computing hardware that we can implement those techniques in machine learning, and then we have the AI. So we will start with a go, no-go screening. That's the first step to remove some of perhaps not very practical concepts. To do so, we need to state some requirements in the form of questions that to be addressed for each concept. The response to these questions will be either yes or no. And then we'll look at the each concepts. If there are many no, it means that concept is not useful. If there are few, maybe we can still keep that concept and make some adjustment, which we will get to the details shortly. The second approach, which is comparing concepts with each other, is the decision matrix method. This method is also known as Pugh method or Pugh charts, which is named after the scientist Stuart Pugh. Well, this method compare again concept with each other. I would say this method is very effective if each team member, let's say you have a team of 4 or 5 working on a project, each team member separately create the Pugh chart and the scoring, and then you compare until the results or all team members are on the same page and agree. Perhaps using an Excel spreadsheet, make it easier for the calculation. I'm just going to show you an example shortly so you know what is this method. In principle, these are the 5 steps that you need to take. Step number 1, choosing a set of criteria, which they all go in the first column here. Step number 2, you have already generated some concepts. So concept number 1 goes in column 1, concept number 2, concept number 3, and so on. Depends on the number of concepts that you have. So you have to have some weight. Some of the criteria are more important for you than the rest. Perhaps maybe cost is less important for you in a design comparing with safety, or maybe weight is more important than cost. So you have to give some weight to each criteria. You have your concepts. You choose one of the concepts as the base, or we call it a datum, and you compare other concepts to these datum. If the concept that you're comparing is better, you choose a plus sign. If it's worse than your base concept, you give it a negative. If it's the same, you just use S or 0. You do the math for each column, considering the weight, and that gives you some scoring for each concept. I'd better get into an example so you have a better idea. Remember in last lecture, we talked about designing a modern forklift. And if you didn't have a chance, please go back and check that lecture and see the design that we came up. Okay, now let's score those concepts. Let's just focus on the lifting mechanism, again, for simplicity. Let's assume we have 4 concepts for the lifting. We decide to go with the hydraulic ram. Maybe the second concept would be using rack and pinion gears, a screw, power screws, or maybe a chain hoist. All right, so we have 4 concepts. Second step, so that's our step number 2, generating the concept. Step number 1 was set of criteria. So our criteria, let's say here, is cost, efficiency, the capacity, the load capacity, manufacturability of the concept, safety, how easy it is to operate it, speed and range of motion. Okay, we need to decide for some weight which of these items are more important. Is it the cost that is more important, or safety? Should I give it rank first and maybe cost 2, and maybe a speed is not that important for me and I give it rank 8? So it's a voting mechanism. So if we have a few team members for a design, perhaps we can vote and decide and then use the average to rank these criteria. As an example, I tested these and I asked 49 people that ranked these for me, people who are familiar with forklift and perhaps they have operated it, so they can give a better opinion. If you don't have such a people available, maybe you can ask people with experience, or maybe other team members, or some public that know a little bit about a design. So this is the result. According to these 49 experts, the safety was the most important criteria, and their second most important was cost, and so on, and the speed was the least important. Now I need to decide for some numbers. Maybe I'll give the weight. Remember the weight, it's up to us. I'll give safety 10 and maybe cost 8. Again, we can decide based on these for some numbers, speed 3, and so on. So a range of numbers from 1 to 10, or maybe 3 being the lowest, weight to 10, because the speed still is important. Okay. Let's assume we did the weighting. Now we have the Pugh table, right, or Pugh chart. So as you see, this is in this table format with the title, lifting concepts. First column is our criteria. Second column is the weight. And here on each column, we have the rank of we are gonna actually have the plus minus sign for each concepts, right? See, here are our concept. And at the bottom, we have the total weight total. Okay, so these are the standard table. For your design, you're going to have the same table, of course, with maybe, hopefully, with more columns. Since you have more maybe concepts and maybe more criteria, you can add more criteria as needed. So let's just, based on what we just discussed, um, again, let's say I'm team member number one. And as a team member number one, sorry. So the weight that I chose is 7 here, 8. I have 9. I have 6. And I have 10, 8, 3, and 7 there. All right, so these are the weight that the expert suggested, or I thought this is an appropriate weighting for each of these criteria. As you see, safety is the most important, and speed is the least important. And after safety, it follows by efficiency, or sorry, the load capacity. Uh, Now I need to choose a datum, a base concept. Um, we can choose the hydraulic ram as our datum. So this is gonna be our datum. It doesn't have to be in the first column. Keep in mind, it can be anywhere there, but it's easier for the calculation if it is in the first column. You can play with it and change its position, but it can be any of these, the datum. So the datum has the rank 0. It is our, let's say, baseline, right? Now, we are going to see for each of these concepts based on the criteria if they are better, same, or worse. If they are the same, we'll just give them S. For example, cost, I would say rack and pinion is the same as hydraulic. And I would say screw is more expensive, so I'm going to give it negative, so it worse. And chain host, I would say, is the same. You may disagree, so you can have your own table. So 4 or 5 team members, each different ranking, and then we compare and we iterate until we are all on the same page. And let's look at efficiency. Efficiency, I would say rack and pinion is more efficient than hydraulic. Screw is more efficient. And even I say chain is more efficient than hydraulic. Hydraulic sometimes can be not that efficient. So what about the load? Everybody knows load with hydraulics. Hydraulic has the most power, so this is gonna be worse. What about the manufacturability? Rack and pinion is harder. You need to make really good gears. Machining is more difficult. Screw, again, this power screw, perhaps more difficult to make. And I would say chain is the same. So what about the safety? I would say hydraulic is the safest because the rest involves some mechanism. So I would give these being worse than safety. So we'll continue with ease of operation. I would say they are all the same as hydraulic. Perhaps speed, maybe rack and pinion is a little bit slow because it involves gears. Um, Perhaps screw is faster, especially if you have a good power screw, it can rotate fast. And chain is going to be worse. What about the range? I would say hydraulic has the range of motion, has the best range of motion, so all of them are going to be worse than that. Now we need to do some math. We multiply each of these by the weight and we add them. Of course, this one is going to be 0. So you can have the total as well if you want, but we are going to just focus on the last column, the weighted total. But you can have that as a comparison. So this is going to be 0. So remember, S is equal to 0 for us. So 0 multiplied by 7 is 0, 8. We're going to have 8 here, minus 9, minus 6, and minus 10. Remember, I multiplied them by the weight. Here is 0, Here is going to have -3, and here is going to have -7. If I add them up, and hopefully I did my job well, but please do the math yourself and correct me if I'm wrong. If I do the math for the second column, it's going to be -28, and for the last one, -21. Now I have a ranking. So according to the scores that I got here, this is my rank number one, like the best design so far. This is rank number two. This is going to be a rank number three, and this is the rank number four in this design. Now that's my job. I pass it to the second team members, and they separately, independently, without they looking at my score, they do their uh, scoring, and let's say they came up with this number. So according to them, again, they chose the datum to be the same, the hydraulic, and as we see, it seems this is their rank number one, and here, so we have -5 and -5. So if we got to the same number, we cannot be picky. So we'll go with just rank number two, rank number three. It doesn't matter because we are going to iterate anyway. And this is going to be a rank number four. So each team members will repeat that, and then we will compare, we rank again until our ranking or scoring is the same for all the team members. Just keep in mind one thing. What if after you do the scoring, your best choice becomes, let's say, the screw one, the different concepts. So keep in mind that is going to be your datum, right? I'm going to repeat it again. If after ranking, you found out that another concept, let's say the screw concept, just as an example, became rank number one, then it's going to take the place of the datum. That one is going to be the datum, and you compare the rest with that one. All right. So here is my suggestion. Do this for your project. So to summarize, select a function from your design. Like here in the example of forklift, the lifting was the function that I picked. And then choose the selection criteria for each, right? It can be 8 to 10 or 12 criteria. The more would be better. Choose the weight. That's important. Do not go with weight one for all of them. Keep in mind for each design, it's different. Perhaps maybe cost is not a big deal in your design and safety is a big deal. Maybe you're designing something for an airplane, which weight would be the most important. So you don't need to worry about the cost. So weight and safety is more important. And you review and discuss that. Thank you very much for listening.